Automatic reference counting, ARC, deals with Objective-C objects. Nothing changes about how you use ints or floats or chars, just objects. And nothing changes about the way you create your objects. You don't make your objects in some special new way. You use alloc init or convenience methods the same way that you always have. And we still use these pointers to our objects. And it's your pointer variables that are the most important piece of the ARC world. It's how ARC can detect that this object is still relevant. As long as it can tell that there is a variable that's accessible, that's in scope, somewhere in your application, and it points to, is a reference to an object, that object will continue to exist. So ARC considers these normal object variables, regular pointers like these, as being what are called strong references. It is possible to create what's called a weak reference, but that's a topic for another time. And it's a regular, strong reference that keeps the object alive. And as it goes through your code, when ARC detects that there are no more strong references to an object, perhaps the variable pointing to it has gone out of scope, or it's been set to something else, or even been set to nil, ARC will generate the code to release the object and the memory will be reclaimed. Now, it's important to understand that ARC is not garbage collection. If you have experience in a garbage collected language like C# or Java, recognize that ARC is not the same thing at all, because while it is automatic memory management, it's being done at compile time, not at runtime. Garbage collected languages need a constantly running part of their runtime that monitors memory usage of an application, and then it jumps in to clean up when things get too big. This is what's often referred to with the wonderful term of non-deterministic finalization, meaning you can't determine, you don't know exactly when it will happen. And that can lead to slowdowns in garbage collected applications when memory is being reclaimed because it happens unpredictably. Now, this wasn't acceptable to Apple, and garbage collection as a technique for memory management was never implemented in iOS, although it did exist in Cocoa on the Mac desktop. But know that garbage collection as a technique in Apple development now pretty much goes away. Forget about it, and we're not going to cover it in this course. ARC is a much better way of doing it. We don't have some big memory management layer that's slowing our application down at runtime. It's exactly the same runtime model as before, because it's the compiler that's already done the work of figuring out exactly where that memory management code should go before the application is ever run.